Once I say that, huh? What's that? Right. So as I was saying here, if we have two forces, right? One horizontal and one vertical, where would the resultant be? Diagonal, right? So there will be a diagonal force here, and that'll be our resultant. How you spelling it again? What you can do? How you can find this? We can use the trig ratios, right? So let's just make sure you all remember how to do that. So we have a 6 Newton force. Remember in CSEC physics, we used to use something called parallelogram law, right? We do a scale diagram and then measure it, right? But again, you can use Pythagoras theorem if you want. 6 Newtons, 8 Newtons, and the resultant is here. So if we want, we could create a parallelogram, right? Here's 6 Newtons, here's 8 Newtons, here's 8 Newtons. This is a right angle. So to find the resultant force, it will be the square root of 8 squared plus 6 squared. Answer is 10. That's okay? So I just trying to make sure you remember how to do that. And force is a vector quantity, right? So you should also have some direction. Joseph? Yeah? So how we getting alpha? Alpha will be tan inverse of 8 over 6. How much is that? Let's check it from the class now. Degrees, huh? Page 21. All right, nice. Everybody okay with that? So if we have now, so think of the concept, right? So if we have right, if we have a force at an angle, what can we say about that force at an angle? So think about this here. Think about this force here, that's 10 newtons at an angle of 53.1. What can we say about that force? What can we say about a 10 Newton force at an angle 53.1? What we could say is that force has a component in the horizontal direction of 6 newtons. And it has a force in the vertical direction of 8 newtons. So what that means is a force at an angle has components. What's that? English? A force at an angle has components. You okay with that? You sure? So if I give you a force at an angle, this force has two components, right? It has a horizontal component, I'll call it Fx, and it has a vertical component, Fy. That's okay? We need to be able to find those components. Everybody okay with that? How do we find those components, right? Okay, oh, yeah. So how do we find those components? Right? Extremely simple. All we had to do is just like parallelogram. Right? Just like parallelogram law, all we have to do is this. Take the force F and recreate like same parallelogram law. Here will be the x component, here will be the y, or here will be the horizontal, here will be the vertical. That's okay? And then apply tricks, right? But to make it real simple, you all remember cos is always what? Adjacent over, and sine is always opposite over. So the force that is adjacent to the angle will always be cos theta. The force that is opposite to the angle will always be sine theta. That's okay? No need to go and work it out. You could just learn adjacent cos, next one sine. That's all. That's okay? But if you wanted to see the working, watch this here. If I said cos theta is equal to adjacent over hypotenuse. So when I cross multiply, I'll get f cos theta. You okay with that? So all I really want to learn, next to the angle, cos, next one is sine. You okay with that? So now, this is how we find the components of that force, right? So in case to complicate things, they're not going to give you anything horizontal or purely vertical. They're going to give you a force at an angle. And we have to learn to break it up into the components so that it will look like a normal C-set question. That's all right? Copy it down and let's put some numbers in there. Okay, so far? So we want to try a couple examples. Right? Let's find the two components here. What direction will the horizontal component be? To the right? What direction will the vertical component be? Right? Let's resolve it. Do it mentally real fast. What would it be? Fx is what? The force, cos or sine, next to the angle, right? And if one is cos, the next is sine. And you're done. Right? You are done. Let me change it up slightly. Find the two components here. Show me the direction as well, right? Find the two components here and show me the direction as well. Right? Now we we've got the back, right? She's looking at that, right? Right. It's good. It's good. My apartment. Ready? So, what direction is the horizontal component here? Nice. Right? Think about it, right? If an object sliding down here, it's sliding towards me and sliding down, right? That's how you can kind of figure out your direction, right? So you have your fx here, fy. Fx is adjacent, so fx is 50 cos 30, and fy is 50 sine 30. Some of you might be saying that that's okay. Some of you, huh?
What do you mean by that's no, to the left.
Oh no. I just write in the when I result. I'm not putting the signs here. I'll put the signs when I combine them. Right? The reason I'm not putting the signs because I show you the direction here. Right? I'll say that. Right. So you might be asking, well, so far for every single question, FX was cos. Why you just gotta learn it like that, right? And let me show you why I don't want you to learn it like that. Look at this. Look at this third version here. Do the same thing from the right. 10 newtons. And here is 40 degrees. Find fx, find fy. Show the direction so you don't have to write the sign, right? Find fx, find fy. Show the direction so you don't really have to write the sign. Finish. Online, any issue, just message, right? Alright, ready? So what direction FX is? FX is where? To the left. FX is here, FY is where? FY will be upwards, right? So which one here is adjacent, FY or FX? FY is adjacent or next to the angle. So it will be 10 cos 40. And therefore here will be 10 sine 40. All right? So FX is not always our cos. You all okay with that? You all see why, right? So FY is adjacent to the angle. So FY will be cos. And if one is cos, the next is sine. Any questions? All okay with that? Right. So now, let's say we have a scenario like this. Let's say we have a scenario like that, right? We need to figure out how this object will behave. So we have two forces acting on it, a vertical force of 4 newtons and a force at an angle of 30 degrees to the horizontal, a force of 10 newtons at 30 degrees to the horizontal. We need to learn to find the resultant. So the first thing we do is we resolve all the forces, right? After we resolve all the forces, right, we resolve I just put it differently. We find the resultant horizontally and vertically. And then we apply Pythagoras theorem. So we have 3 steps. Step number 1, we're going to resolve all the forces that need to be resolved. We're going to find the resultant horizontally and vertically, and then apply Pythagoras. Okay, watch here now. I'll like copy it down this now. Okay, so we're going to apply step 1. 4 newtons. Do I have to resolve 4 newtons? No, because the 4 newtons can only act downwards. Huh? Yeah, we add them in just now. Here now. This 10 newtons force, right? Could be resolved, right? Resolve means finding its components. So this 10 newtons force has a component here and a component here. You okay with that? Yeah? So the component horizontally will be 10 cos 30. And vertically it will be 10 sine 30. Right? So we resolve this one horizontally and vertically. Are you okay with that? What's the next step? The next step is to find the resultant vertically and horizontally. So step number 2. If I were to resolve 10 sine 30 and 4, what you'll end up with? right? As what's the name again? As Adam was saying, we had to add signs now, right? One direction positive, next direction negative. One direction positive, next direction negative. That's okay? So it will be 10 sine 30 plus minus 4. So that's 5 plus minus 4, and I got 1. Everybody okay with that? Put this in the calculator, right? 10 sine 30, that's 5. 5 minus 4, or 5 plus minus 4 is 1. Going upwards. That's okay? Emily? That's okay? It's not Emma? What's your name? Emma. So Emma, what about horizontally? Anything to minus? No. So I'm left with 10 cos 30, which is?
No.
No, kind of fine. I think it's 5 root 3 or something. 5 root 3. Everybody okay with that? When I reach here now, how you find the resultant? Where is the resultant actually? Here, right? Now is where we use Pythagoras. So the resultant will be the square root of 1 squared plus 5 root 3 squared. And then you need an angle because it's a vector quantity. The angle will be tan inverse opposite over adjacent, right? Anybody confused? Right, so in CAPE, this is what you will see. But of course, I'm going to add in some more things now, right? How much is this?
2,
Huh?
19.
2 root 90. And here's how much? Tan inverse 105. Huh? 6.6 degrees. Okay. Questions online? Who? Eden? No, I see. I'm right there, Eden. Who's that? Who I'm with?
Yeah.
I'll ask him the next one. Yeah. Right, so the resultant force for this example here is 2 root 19 newtons by 6, the angle is 6.6 degrees. Right? You don't have to write it in suits, you can write the exact you can run it off if you want. Try this one, you know. Right, so we're down to food, right? Down to food, right. Right, but you see that one direction, well, the next, right?
Yes, sir. What? Oh, I didn't.
Alright, let's see. Oh, you got me out. That one, alright, one, check it here. So let's see, step number one, I'm going to resolve. Here's 6 newtons. Here is 14 newtons. And I'm going to resolve 20. Here will be 20 sine 45. And here will be 20 cos 45. Right? So when I resolve, I will end up with 6 minus 20 cos 45. I got 8.14 here. 8.14 there. And 20 sine 45 minus 14. And I got upwards, right? 0.142 newtons. So my resultant will be here and my angle is here. So my resultant will be the square root of this squared and this squared, which should be close to 8 point something.
Yes. Yes.
So I got 8.14 newtons. And the angle will be tan inverse opposite, which is 0.142 over 8.14. Amrit, you got through with us? Yeah, you get out? All right, thanks. So the answer is 0.99.
Yeah.
Right?
Yeah.
But that's without rounding off. Right? So you're rounded off. So from that side. 0.7, yeah. Once it should have now, yeah. Well, once it should have made substitution, yeah. Nice. So that's the way you resolve. Everybody okay with that?
Yeah.
Right, we'll do some more just now, but I wanted to take a small little note here. Small thing. What does the word equilibrium mean? Right? And in terms of resultant, what does equilibrium mean? Resultant. Resultant is zero, right? So if I said that an object is in equilibrium, it means that when you work out, the resultant is zero. And if I give you this diagram here, right? And I said that this object is in equilibrium, what does that also mean? It's now moving, right? So it means the upward has to be equal to the and the left equal to the right. That's okay? So sometimes they can give you the reverse and say, well, here's what? Find F if the object in equilibrium. Okay? So write this down. A system is said to be in equilibrium. A system is said to be in equilibrium if its resultant is zero. If its resultant is zero. If its resultant is zero. That is the upward and downward forces are equal. And the forces to the left and right are also equal. And the forces to the left and right are also equal. Did I send up? Did I send up PDF in the group? With some questions? Huh? Yeah, like a day or two of it. No? Sent in your own group, buddy. Alright, the values might be the best in the world, right? But let's try this. Given that the following is example one. Example one. Example one. Given that the following system is in equilibrium. Given that the following system is in equilibrium, find the value of F and the value of theta. Given that the following system is in equilibrium, find the value of F and the value of theta. Okay, so look at that system there. It's in equilibrium, right? So it means that upward equals to downward, left equals to right. So what's the first thing we have to do? 4 up and right. Well, you close state, but you have to do before that. Before you do that, you have to resolve. You have to resolve F. And then Then you equate horizontally and vertically and solve.
What's it? Why we saw the it will be equal anyway. Because in one of the situation, right? For someone 10 on the bullet,
Right? So you mean,
that's why. So I got a result with
oh, because, yeah, so yes, you have a 10 here and a 4 here, but what's the value for f and theta? That'll give you that. Right? But there's a next thing you can do as well. Anybody seen it? I thought that's what you're good and see.
so you could find from you could find f by utility 10 on your 4.
Very good. So what you could do is just find the resultant here. You'll realize that. If you find the resultant of these two and find the angle, and the same thing, right? That could also work, right? Right, but do it this way. Resolve f,
Yes.
right? Resolve f horizontally and vertically. And then solve it from now. Come on, right? That's what I'm trying to figure out the way I said it. Sorry. PDF. Right? Kabuzara. So that multi yourself. Resolve here from what you get. F what? That's no sign. F. There's a adjacent, so that'll be F cos theta. And here's what? F sine theta. It's in equilibrium, right? So since in equilibrium, left equal to right. So F cos theta is 10 and F sine theta is 4. That's okay. What are you doing next? Well, you want to help. Now, I'm putting this sign on top, right? I'm putting this sign on top for a reason. F sine theta is 10 and F cos theta is 4. Any ideas? You gotta solve simultaneously. What do you do?
So we don't so yeah.
Yeah, sorry. How will you solve something like this, much people? Which is you two, Zara. What do you think? Yeah, you can make F the subject and put it in. Or something easier, as it right there. Huh? Tricks, right? How we can get the tricks? What to do? Tan. So we can divide this. See that? F will cancel. So you will get tan theta is 1/10. So theta is equal to tan inverse 4 and 10. How much is that? 6 point a number, very good. Tan inverse of 4 and 10. 21.8 degrees. Right? Online, let me see if anybody send any answers. Nothing. And then F. Then you have to work out F. F will be 4 over sine 21.8. How much is that? How much is that?
10.7.
10.8. That's okay? That is how we handle it, right? As I said, we could have also find 10 squared plus 4 squared. 10.8. Yeah. Any questions there earlier? Anybody confused? Emma? Confused? Which part? Tell me which part. Okay, so let me start back here. The whole system is in what? Equilibrium. What does equilibrium mean? Up equal to down, left equal to right. Right? So the problem is this is at an angle. So I have to resolve it. Vertically, horizontally. You follow how I got tan cos. Angle here. Next to the angle is always cos. Next one is sine. You okay with that? Sure. So we just said it's in equilibrium. So it means upward equal to, see that? And left equal to, well, right equal to. You okay with that? Now we had to solve it. Zara said we can make F the subject and substitute. That's okay. Right? But what I decided to do was just divide them because I have them right there, right? F will cancel. Sine and cos is tan. And I will get 4 and 10. Tan inverse, I got that. And then I plug it in here and I solve that. That's okay? Well, if you don't understand, don't be afraid to say, right? I can't read all the faces yet. I forgot to come up face there now. I look like you. Are you okay with that? Right, let's do our worded version. Up on the which one? Ready? Everybody ready? Do I give you a hard word for it?
Yeah.
Yeah? Okay. There you go one time. A 25 kilogram box. Well, that's a hard one, right? So I'll give you one that considered to be kind of hard. Those who doing applied, this question is like applied unit 2, module 3. Right? A 25 kilogram box, 25, kilogram box is on a smooth incline. A 25 kilogram box is on a smooth incline of 20 degrees. 20 degrees. Full stop. Find the component, find the force F. Find the force F that is needed to hold the box in equilibrium. That's part one, right? Find the force F that is needed to hold the box in equilibrium. It's like a medium type question, right? Take your time. Take a little read. You have to produce the diagram. Now, I'm giving it up because I didn't show you friction. Oh. We have the earlier. Diagram is the most important thing here, right? And let's pass around to watch the diagrams. Right, so what is the main thing acting on the block? See some good diagrams, but some of you all forget it's a box, I mean. So you have the horizontal ground, you have your block, right? And it's 20, sorry, your plane 20 degrees, right? And you have a block here. I keep saying block, I mean box. How heavy is the box? 25. Right? In Cape, you don't really use 10, right? We use 9.8. right? So what will the weight be? Right, the weight will be 25 by 9.8. So gain the habit of using that value. How much is that? 2. Right. So the force acting downwards here is 245. Right? Think of what will happen naturally to that box. All I'm here. Slide down. But what's the question I asked for? Was the force required to? So it has to have something permanent. You have to figure out that force. Right? And then I will complicate it a little bit more in the next one. Right, Joseph? Remember, everything we learn in the math side of it, we had to apply it, right? In physics. So I want you to learn to see these things. Diagrams will help you see it. Wait, what time does it happen until? Right, very soon I might extend. Not right now. Oh, I'm gonna get used to school.
I guess in our Navy is just I want to go on to very good at matrix.
Huh?
It's the matrix. Yeah, school of library rush. School is in the
See, I have tried something out for you. Right, so you need a little maths here. The trick is to figure out. Right, the trick is to figure out. Well, of course, we try to figure out the force here. Emma, you okay with that? We're trying to get an F, right? But we had to figure out now what will be the force here, because the weight will act where? The weight will cause it to go downwards, right? So we need to figure out this. What is that force? Because if you figure out that force, then F is what? Same thing, right? I'll give you a little minute to tax your brain. Perpendicular, acting vertically downwards. So, yeah, vertically downwards, that's actually otherwise. As yet. It acting vertically downwards, yes. I'll tell you this now, right? How to figure it out. I don't want to hard one, so I'll give you I just want to see how you resolve. If you figure out how to resolve, you get the answer. Right, so you have to find a way to resolve, right? You're gonna get some trouble there. Over there. Yeah. All right, so watch here. Everybody watch here, right? I shall draw the diagram a little bigger, yeah, but watch this here. That's the block, right? This force, remember, the only way it's sliding down is that this force must have a component here. Right? So it's sliding to the left. Sorry, it's sliding like this and like that. That's okay? So watch this here. This force has two components. One component acting here and one component going down the plane. So there's one perpendicular to the plane and one horizontal to the plane, or parallel. You okay with that? This angle here is 90 degrees, right? So I just kind of join it back here for you, so you will see it. That is 245. There is one perpendicular to the plane and one parallel to the plane. Here is 90. Here is FY. We don't need that. We need the one parallel to the plane. That's okay? Right? But the problem is we have no angle. So we have to find an angle. Right? Watch how easy it is, right? Watch how easy it is. So I just join a line down here. Here's 90, and I just joined this line down here. Here is 20, here is 90. So how much is here? Right, so here's 70, right? That's okay? So if here is 70, how much is here? Inside here. Inside here. 20. Y'all seeing that? I drew the diagram a little too small, right? But here is 20, here is 90, so here must be 70, right? And if here is 70, then here must be 20, right? Because this and this perpendicular. So if here is 70, here is 20. That's okay? So if here is 20 and here 245, then here will be 245 cos 20, and here will be 245 sine 20. So here is 245 sine 20. So therefore, F will be 245 sine 20. Very good. I didn't say yes or no yet.
Why have to take?
Huh?
He's gonna say.
Right, but that's very good. You're okay with that? Right, we have one more.
What time of the?
I'm real time.
Is that-
One more, and we're done. I want to make it a little more complicated.
Alright, yeah.
Last one, I promise, last one.
So. Alright, that would be good. So.
Online, you're okay with that? So F has to be 245 sine 20. Online, you're there still one more, right? Either there still? Yeah, all right. So either you'll send me some answers to this one, right?
That's what, so, Keisha,
Who?
Keisha, here,
Teacher Parliament, I was on you so way. Alian, suppose this surface was rough. What you gonna do? Yeah, if something's sliding but the surface rough, we have to include what? Bricks. Right? But we're doing that today, we're doing that later.
I don't really want to do it again.
Last question. Diagram most important thing. Yeah, diagram wrong, you get this whole thing wrong. Am I you okay with this one here? Stopping and border. Most important thing is that diagram. Question different. Question said horizontal force E is applied.
Yes.
Are you ready? So watch this here. This one here, the acting vision, of course, that particular force P. P acting horizontally, right? So yes, you could put it here, but can we also put it horizontally like this? Like in horizontal? Can I apply it like that? Yeah? So if I resolve P, how will it look? If I resolve P, actually let me put another angle here for you. What's the angle here? 45, right? This is the same as this. This line is the same as this. So it means that here must be 45. See enough? This and this parallel, this and this parallel. And if they meet, they'll meet at the same angle, 45 degrees. Right, Keshav? Keshav, I need a little help. I want to resolve P. Right? If I resolve P, it will be what? It will be where? Up here and where? It'll be up here and down. Very good. Very good. So here's what? Cosine or sine? Angle is here. So here will be P cosine, right? 45. And here will be P sine 45. You okay with that? W now. W, if I resolve W, just like the last one there, here will be W cos, and here will be W sine. Just like last time. You okay with that? Yeah? So now, what we can say, oh, by the way, what was the mass again? What was the mass? 2. So it's 2 by 9.8, which is 19.6. So if we resolve here, right? If we resolve, right? Let's resolve parallel to the plane first. Right? What we can say? If we resolve parallel to the plane, what we can say? W sine 45 equal to what? W sine 45 equal to P cos 45. Everybody okay with that? Adam, you follow why I put P here, right? So I can resolve it parallel to the plane, perpendicular to the plane. You okay with that? Everybody okay with that? Right? So we can solve this here. We know what is W. So now P will be equal to W, which is 19.6 sine 45 over cos 45. This will cancel. So you'll get 19.6 meters. Right? These two are the same. So you'll get back the same value. That's okay? So the value of P is 90.6. What they ask for again, that is something else. Normal reaction. What is normal reaction? I pick somebody new now. Dante, what is normal reaction? Normal reaction is contact force. Right? When an object in contact, that's normal reaction. How you find R? R is what? It's not moving, it's in equilibrium. R is what? W cos plus P sine 45. Pretty final answer? 27.7. Right? All okay with that? So, but you all follow why he did that? Because upward equals to downward. Perpendicular to the plane up equals to down here. You all seeing that? Right? If this is looking confusing, forget all of this and bring it back parallel. Right? Bring it back horizontal. You will see that these two are equal and these are equal. See that? Most important thing is a diagram. Right? Applied people, this is applied math question.
Nice.
Module 2, module 3, unit 2. Those who like applied, that's what you're doing. It really come, this is really common physics, you know. The ones that came is the one that they record out with the circle. All right, so that brings us to the end of today. All yeah, and the tech person next to someone and ask people, but we have class like normal, right? Huh? Nah, class. Huh?